Kia ora koutou, Reese from QuickSense here, and today we're solving equations using graphs. Now, the way we're going to solve this is we are trying to make one of the sides of the equation the same as the other. So we've got two different expressions here. We've got one, y equals x squared plus 3x minus 5. Weird. 2 is 0 equals x squared plus 3x minus 1. And what I want to do, really, it's the only thing I can do at the moment, is make this side equal to this side. So I ask, what's the difference? Well, the only difference here is in my term at the end, minus 5 and minus 1. How do I make them the same? Well, I have to subtract 4 from both sides of this equation. So this becomes negative 4 equal to x squared plus 3x minus 5. And now that they're the same on the right-hand side, I can say that y is equal to negative 4. Why is that helpful? Well, I can use my graph. I'll use a different color here. Use my graph and draw in y equal to negative 4. This gives me some points, right? What are the roots? Well, that's all that means. What are they? Well, I'm going to now move up here, and we can see that the points of this equation, whatever these values are here. And to my eye, it looks like the roots are negative 3. Let's get rid of this purple. Negative 3.5 and positive 0.5. Now this next question, it may not be obvious immediately how I'm doing the things that I'm doing, but what I would suggest is that it is a matter of playing around, being okay, being resilient, and trying to make, again, either the right-hand side or the left-hand side equal each other between these two expressions. So we've got our two expressions again, one up here, two up here. And we're trying to find the solutions to this equation, or the roots of this equation. We're going to play around with number 2, and we're going to try and make it something equal to 6 over x squared plus 1. And I have no idea, really, how to do this ahead of time. But what I can see is, I'm just going to try and make this as simple as possible for myself. And I'm just going to add 6, right? I can see this 6 here. I think, right, well, the first thing I want to do is just add 6 to both sides. Add 6 there, add 6 there. That becomes plus 4, and that's 6. So I've got that 6 part. Now I need to find x squared plus 1. So in my mind, I'm trying to figure out, can I factorize x squared plus 1 on the left-hand side? I can definitely factorize x plus 4, so that's what I'm going to do. So x plus 4, right, let's have a look at that. So the common multiples here are, well, let's go x squared and then I go 1 there. Right, I can factorize that again, giving me x squared plus 1, x plus 4, here we go. And now we can see, right, now I've got this figure here. So I'm going to divide both sides by that, giving me x plus 4 equal to 6 over x squared plus 1. Perfect. This tells me now, this is telling me loud and clear that y is equal to x plus 4. Well, what does that look like? Well, I know it's got a gradient of 1, and it goes through the y-axis at positive 4. So that's going to look Excuse my bad drawing. Something like that. Oh, I'm going to miss one of those solutions if I don't carry on. All right, so find all the solutions. So you can see that there are 3 solutions, and we're going to do this approximately, right, as approximately as we can. I'm drawing it down to the x-axis. What are the roots of this? Well, the roots are down here. We've got, that's -3, so that's -3.5. We've got going down here, -1, and that's going to be 0.5. So all the solutions, well, I've got 3 solutions, -3.5, -1, and 0.5.